All right, so this is still talking about the pressure, wind, and weather slideshow. And in this particular lesson, I'm going to talk about what the H's and L's on a weather map mean in addition to these squiggly lines. Because when you see a weather map, you'll often see these H and L's separate from one another. Those are high and low pressure systems, but they'll usually be surrounded by these lines, which are called isobars. An isobar is just a line of pressure showing you the pressure on a weather map. If you think back to when we talked about how we measure pressure, we use a barometer, and normal pressure with a barometer is 1,013 millibars. And if you could look closer at some of these lines on the weather map here, you can see that this one right here says 1,024. So it's actually higher pressure, which makes sense because it's near a high on the map. And anywhere on this squiggly line around the H, anywhere on that line, the pressure is 1,024. And then if you look at the next line out, that one's 1,020. So anywhere on that line, the pressure is 1,020. So these squiggly lines tell you the pressure surrounding these pressure systems. Now, just like if you're hiking and looking at a map for, you want to see how steep the mountain's going to be. You look at contour lines on a map for hiking. The closer together the lines, the steeper the hill. It's the same thing with isobars. The closer together the isobars, the steeper the pressure increases, the quicker it changes from line to line. And so close together isobars tell you that it is very, very windy. The closer together they are, the windier it gets. As opposed to these spread out isobars with a lot of space in between. On a hiking map, that would indicate, a nice gentle slope to walk down. Gentle wind, or rather spread out isobars tell you that you're going to have light winds. So just looking at not even the numbers on these isobars on a map, just looking at how close together they are, you can get an idea of windiness and wind speed. So again, the closer together they are, the steeper pressure, what we call gradient, that just means the slope, how steep it is. And the closer together the lines, the faster the wind speed. If we look at those H's and L's in a little more detail, I want to talk about those next. The H's and L's are usually surrounded by isobars because they're the center of a high or low pressure system. Something has happened in that region to make the pressure higher or lower than everything else around it. And remember, we talked about the three ways to change pressure. Either the altitude is higher, maybe this pressure system formed over a mountain. The temperature could be higher, maybe it formed over a warm patch of ocean. And the humidity could be higher. Maybe it formed over ocean in the first place, and therefore would be a lower pressure system. So these H's and L's form in places and then move across the map, taking their pressure with them. The H's are called anticyclones, which I know you've probably heard of cyclones. So we're going to talk about those next, but an H is an anticyclone. It's the opposite. The most important thing to know about an anticyclone, an H. I don't care so much about you knowing clockwise versus counterclockwise, but the most important thing to remember about a high pressure anticyclone is that pressure flows from high to low, so air is moving out of a high, and it's also moving down. So an anticyclone has air moving down and out. The downward motion is important because as air gets closer to the surface, it warms up. Just like if I can get air to rise, I can get it to cool and condense into clouds. Well, if I can get air to move down, I can get it to heat up. So a typical saying for anticyclones is that it is clear and dry in a high. So you would expect on a high pressure system on a weather map that it's not very cloudy. It's probably not very windy either. And it just tends to be a nice dry system. It's not very humid at all. So clear and dry and a high. A high is an anticyclone. A cyclone is the exact opposite, of course. These are low pressure systems. And in these systems, the air is moving in because pressure flows from high to low. So it's moving in and up. And as we just talked about, if I can get air to go up, it can cool and condense into clouds. So there's no catchy saying for this one, but in a low pressure system, you can expect it to be very cloudy and you can expect the air to be rising upwards. So a small scale cyclone, the smallest type, is a tornado. And if you think about a tornado, it's a swirling cloud. A larger version of a cyclone is a hurricane. And again, swirling massive clouds. Air is going up, cooling and condensing as more air flows in and adds itself. And then the really big cyclones are mid-latitude cyclones. We talked about Alberta clippers in class a little bit. Just the idea that a mid-latitude cyclone is a large pressure system that can, in this case, you can see how this one covers almost half the United States. So these can be really large, low pressure systems. So that's it for isobars and for wind. The next lecture is going to be about some smaller scale winds. Instead of the whole weather map, we're going to bring it down to some local and regional wind patterns.